Okay, so this is Siemens TIA version 16. So this is really for my benefit, improving some concepts. So imagine you have an instrument in the field. So maybe this is a rotary encoder of some sort, and it's giving you a sinusoidal output. And the sinusoidal the frequency of the output is relative to the speed of movement. So the rub is the it's a very slow moving signal. So you're sort of looking at like one second of revolution. This type of speed. So very slow. So I knocked up these two blocks over here, this FC and FB block, just to prove the idea. So the idea is this is the instrument, and this is the bit of code that actually tracks the frequency, and it's in radians a second. So it's a bit of a pain dealing with radians, but you know. Now, very simple code. So you look at the instrument, this is just basically a rolling number around 6.28. So rolling around one revolution basically. So like I said, all a little bit rough and ready, but yeah, this is just proof of concept. There, and there's the frequency tracking. So again, in here, there's a code here. What's that? 1, 2, 3, 4, 5, 6 lines of code. So it's not a lot in there. So let's see what it's doing. So what I've done is I've chucked it to an HMI over here. So this is the HMI, and let's pull up the HMI. HMI looks like this. So here it is. So there I'm tracking at one frequency. You see it sort of locks in round about here, and there I'm tracking at another frequency, locks in there. So the red is the instrument coming in. So I've tracked it around about there. Then I've performed a step change. I've increased the frequency, and that's followed suit. So that's increased as well. Okay, so let's unfreeze that. It is running at the moment. You can see this clock ticking up, very slow basically. Okay, so that appears to work over there. Now, how I developed this algorithm, the way I done that is I actually used the simulation package, because the simulation package is to be honest a lot easier than mooching around the TIA package. It's quicker. So this is over here essentially. So this is the algorithm. So I've basically just developed this, and then I just transpose this to PLC code. That's all I've done. So there's your instrument over there. Differentiate, absolute, constant, multiplied by a constant, and some filter over here, and then read from various points around the instrument. And you can sort of click that and run it, and where does that appear on this thing? Does it appear? I don't think it does actually. Let's get rid of that. Let's run it quickly. It doesn't take too long to simulate this. This is one of the reasons I've used this package, because it's quick. And there it is. Or it's quicker in some instances. It's very slow. And there you can see it tracking. So the black is tracking the input frequency of that green signal, which is essentially our instrument. The red is a differentiation of that signal, but anyway. So you see that it tracks around 4, and just to prove that is tracking, if you come over here, there's our instrument, and I've set the radians at 4 there. So set it at 8 for example, and it should track around 8. And it's fairly quick as well. It picks up the frequency in about 5 or 6 revolutions. You can make it quicker, but then your filter would have to be looser. So let's have a look at that. So that should tickety tockety tickety tock. There we go, and there you can see it's tracked at 8. So there's 8, run across, and there it's 8. So the ripple is actually the filter in action. So yeah, it is quite possible. Another possible way of doing this, and probably a better way, would be using a phase lock loop. So you lock into the frequency of that supply, and then you would have to use a PID and maybe some voltage controlled oscillator in your software. But it might have been a better way, because the problem is once you start doing this DUDT, once you start differentiating, any noise on that will be amplified by this thing here. So if you look at the PLC code, PLC over here, if this is your signal coming in over here, let's say, or here, any sort of noise on that will possibly be amplified. Although there is a filter in there, it will deal with it, but it's just something to be aware of, basically. So your instrument will have to be pretty well guarded against any noise, screened cables, and possibly on some of the cards that you have on the PLC, there is a filtering function on it. So you must be aware of that as well. So this is actually relative to a role that I done not too long ago. They were doing something similar to this, not quite like this, but something similar. And strangely enough, also in Siemens, but S7. And yeah, anyway, so thanks for listening, and ciao.